In this video, I will show how to create the partial fraction decomposition for a given function. To do that, we're going to run through all the factors of the denominator and interpret each one accordingly. First step is to make sure that the denominator is completely factored into the product of linear factors, possibly repeating, and quadratic irreducible factors, which could possibly also repeat. So we do have the product of linear and quadratic irreducible terms here, so we can begin creating the decomposition by scanning through the denominator or through the factors in the denominator. So the first factor is x to the 4, and that means the decomposition will have 4 fractions, 1 for each power of x in the denominator. So we're going to have x squared, x cubed, and x to the 4. And when we have a linear term in the denominator, in the decomposition, the numerators are just some constants. So I'm going to use the letters of the alphabet, so it's A, B, C, and D. Now, we're done with x to the 4, so moving on to the next factor, it's x minus 2. Since it has only power 1, that means the decomposition will have only one fraction with the denominator x minus 2. And again, since it's a linear term, the numerator will just be a number. Next factor is irreducible quadratic, x squared plus x plus 1, and it's to the power 1. That means the decomposition will have only one fraction with such denominator. However, now, since we're writing a quadratic irreducible term in the denominator, the numerator now can be any polynomial of degree 1. So here I'm just going to write some generic linear expression using unknown constants. So continuing with the letters a, b, c, d, e, f, x plus g. And last is the next factor is x squared plus 4. Again, it's a quadratic irreducible, but this time it's to the power 2, meaning we're going to have 2 fractions in the decomposition with such denominator, 1 for each power. And since the denominator has quadratic irreducible expression, the numerators in the decomposition will be some generic linear expressions. So I'm just running through the letters of the alphabet, and we went through all factors in the denominator. Therefore, we're done creating decomposition. So this was the easiest part. The hardest part is actually figuring out the constants. But in this problem, the question is not about finding the constants, but just writing out the decomposition in general form.